Hello, in this video we are going to look at bearings word problems. So I've got 3 questions to get through. I'd recommend you pause the video and have a go at the questions and have a look at what I have to say. Okay, so with bearings, just a reminder, we want to use the Z rule. We want to use the alternating angles on parallel lines are equal. Okay, notice there's like a back to front upside down Z here. So that means we can make some assumptions about angles. So this is 60, then this is 60. So you're looking for these Z's and N's. Okay. Bearings diagram. So this is the process we sort of want to follow. You want to mark in a start and an end point and make sure that your angles and distances are labeled. Then you want to look for right-angled triangles. You're going to see this soon. Okay. A ship travels due west for 16 kilometers, then on a true bearing of 290 degrees for 12 kilometers. How far north is the ship from its starting point? Let's draw it out. Just sentence by sentence. A ship travels due west. Well, we know north, south, east, west. West is that direction. It's traveling this direction for 16 kilometers. I'm going to put a little arrow there and I'm going to write the start. Then on a true bearing of 290 degrees for 12 kilometers. 290. So this is where you're going to overlay your compass. Overlay your compass and put it, actually maybe we've got to make it a different color. Let's make this just a different color. 1 second. All we need is north for true bearings, so that's why I'm deleting things. So we get here and then it says 290, which is over 270. So I am going to 270 and a bit gets us to 290. On a bearing of 290. And for 12 kilometers. So I'm going to label that 12. This was 16. How far north is the ship from its starting point? How far north from its starting point? So this is its ending point. Okay. Now at this point, what we can do, how far north means the vertical distance, okay? Let's do that. How far north is it from its starting point? How far north? You're drawing along lines and seeing what we can get to. Okay. Now we are actually looking for right-angled triangles now, is what I will say. So we want a vertical distance. Now, what can I do there? A vertical distance would mean we could draw a little right angle here. We could draw a right angle triangle. And we can find that little angle here, right? What's that going to be? If the full thing is 290 and we know that this 3/4 of a circle is 270, I'm going to just label that 290 take 270, which is 20. So that angle in there is 20 degrees. All you want to know is how far north is the ship from the starting point. So do you agree? This distance here is this distance here is this distance. They're all north. They're all how far north. So how far north is the vertical distance? So we're finding X here. Now it looks a bit crazy at this point. So that's when I'm just going to draw my little right angle triangle on its own. So this is X. this hypotenuse is 12 kilometers, so make sure you know what's going on. And this is 20 degrees. So to find x, it involves an angle and two sides, so that's our trigonometric ratios, okay? And we can say opposite hypotenuse means sine theta equals op over hypotenuse. Sine 20 equals x over 12. X is being divided by 12, so times by 12 to get rid of it. And put this in our calculator. 12 sine 20 is 4 point, and it says to 2 decimal places, 4.10, and units are kilometers because it's a distance. Now, if that doesn't make sense yet, we've got plenty of practice, okay? So don't fret. A ship travels due south, so I'm going to just draw it as we go, actually. A ship travels due south for 3 kilometers. So mark it in. It starts here and you go on the journey. South for 3 kilometers, then on a true bearing of 130 for 7 kilometers. Then on a true bearing, so you get to that end point and you're thinking about which direction to take. 130. Where does 130 lie? 130 is going to lie somewhere between 90 and 180. So I'll just put it in. Let's call that 130. And while I'm here, I'm going to write in what is this little acute angle, because that might be able to help us. Well, actually, I'm just going to, oh yeah, it could. All right, so if this full thing is 130, have a think about what that part bit might be. It's going to be 130 take 90. 130 take 90 is 40. Now, getting a bit sidetracked. So 130 for 7 kilometers. Now we're at our end here and it's asking how far east the ship is from its starting point. How far east the ship is from its starting point. So east or west means the horizontal distance. We're looking here. We're looking here, here, here. What's going to help us? Well, ideally we want to make a right angled triangle, okay? So, how far east is the horizontal? I can see a triangle. I can see a triangle here. You're looking for a right angled triangle. So here we are. Let's draw it out over here, because how far east, I'm just going to label that. That's going to be the horizontal distance. Okay, so the diagram gets a bit hectic, but you just draw out another triangle. And you've got your distance labeled, and you've got your unknown, and you have that little orange acute angle there, which is nice. We worked that out at the beginning to be 40 degrees. So again, if it involves 2 side lengths and an angle, then it's going to be our trigonometric ratios. We're given the hypotenuse opposite the right angle, and we're given the adjacent. So cos theta equals adjacent, which is x. Hang on. We'll just write the thing. adjacent over hypotenuse, cos 40 is x over 7. We want x on its own. It's like that. 7 cos 40. X is 5.36 kilometers. Okay, that's that bit done. Find how far south the ship is from its starting point. How far south? That means vertical distance, okay? So you can just draw some things. How far south from its starting point? So you're looking at the start to the end. And what are some vertical distances? 1 second. How far south? How far south? How far south is going to be this 3 kilometer bit? See that 3 kilometers? It's going to be 3 kilometers plus whatever this orange bit of the right angle triangle is. So this time we're going to find that bit of the triangle and we're going to add it. So I'm just going to call that bit y. And let's go over here. How far south? What's our plan? We're going to do 3 kilometers plus y. And then we have our same right angle triangle. Our same right angle triangle. Except this time, we're just finding y. So this time it's opposite. Opposite hypotenuse sine theta. Op over hypotenuse. Y over 7. And y is 7 sine 40. 7 sine 40 is 4.50 if we're going to 2 decimal places. But remember our plan, we're not finished yet. We've got to add 3 kilometers to that to get that full distance. That full distance from start to end of how far south. So 3 kilometers plus 4.5. 7.5 kilometers is how far south it's drifted. So yeah, it can get a little bit weird, but just bring some highlighters into the exam, I think. And I think we actually might do this video in the next one because it's a bit overwhelming. So go and take a break and then come find out how to do this next one. All right, see you later.